Now we're going to talk about, so we've been doing multiplication. We've done by one digit, so you've done 2 digit by 1 digit, 3 digit by 1 digit, 4 digit by 1 digit. You've done 2 digit by 2 digit, and you've had lots of practice with that. Now we are going to do some multiple step problems. So when you're doing 1 and 2 step word problems, in any word problem, there are a couple of things that are really important before you ever start doing the math. First of all, when you read through the problem, you've got to think, is all of this necessary? Sometimes they're going to give you stuff that you don't need because it's not necessary. They do it just to confuse you. So you have to think, what do I really need to know? What are they asking me to do? What is the answer that they want? What's my end game? And then, when I know what it is they want, how do I find that answer? Do I add? Do I subtract? Do I multiply? Or do I divide? So before we ever start, we've got to figure out, do I need all of this information? What do they want from me? And how do I give it to them? So then we'll start looking at numbers. So we're going to do the first one. It says, Sheila's garden has 7 rows. There are 13 plants in each row. Each plant has 6 flowers. How many total flowers are in Sheila's garden? So when we read that, do we need all of that? Is all of that information important to us? Well, it is. They didn't give us anything in this one that was unnecessary, so we need all of that information. Then we need to think, what do they want? What kind of answer do they want? And normally you're going to see that question mark where you want that. So we see how many total flowers are in Sheila's garden. So they want to know how many total flowers. That's what they want from us. But how do we give it to them? One thing we're going to do, so we know we need all of this, we're going to go through and box in our numbers. That helps us when we box in our numbers, so we know where to look. So we know there are 7 rows. There are 13 plants in each row. Each plant has 6 flowers. How many total flowers are in her garden? Well, it would probably be good for us to know how many plants are in her garden first, because we have to know how many plants there are to be able to figure out how many flowers there are. So we know that there are 7 rows, and there are 13 plants in each row. So will 13 plus 7 tell me how many? If it's 7 by 13, addition's not going to help me. Subtraction and division aren't going to help me. So I know that I need to multiply these two numbers. 13 times 7. 3 times 7 is 21. My 2 up here. 7 times 1 is 7. Plus 2 is 9. So I know Sheila's garden has 91 plants. And now I know there are 91 plants. Each plant has 6 flowers. Am I ready to find out how many total flowers there are? Well, sure. What am I going to do to 91 and 6? Adding them's not going to help me because there's 6 flowers on each of the 91 plants. Subtracting's not going to help. Dividing's not going to help. I need to multiply 91 times 6. So when I do that, I'm going to break this one down into an area model. 91 times 6. Draw my arrow so that I know where I'm multiplying. I know this ends in a 0. I'm going to go ahead and put that there. 6 times 9. Remember, your 9s, you've got the 9s trick. 9 times 6, 1, 2, 3, 4, 5, 6. 5 tens, 4 ones. 9 times 6 is 54. So 90 times 6 is 540. 6 times 1 is 6. 540 plus 6 is 546. Now, what's important with this is with the word problem, 546 what? Does Sheila have 546 potato chips? Or 546 Christmas lights? No, we know there are 546 flowers in Sheila's garden. That's what my answer means. when you've got word problems, you're gonna have to give a unit. That many what? So our question asked, how many total flowers are in Sheila's garden? We had to do 2 steps. First of all, we had to do 13 plus 7, 7 rows, 13 plants in each row. We had to figure out how many plants first. Then we had to do 91 plants times 6 flowers on each plant. So the first one we just did, that was a 2-step problem. We're going to try again with problem 2. We're going to read through it. We're going to decide, is there any nonsense that I need to get rid of? What are they asking me to do? How am I going to give them their answer? I'm going to throw my markers, what I'm going to do. Marcel has 24 bags of chips. Each bag has 17 chips in it. How many total chips does Marcel have? Is there any nonsense answer? Any nonsense information that we don't need? No, there's not. We need all of that information. So now we're ready to go on to what is it that they're asking us to do. I'm going to look for my question mark because that's going to be my clue. They're asking how many total chips. I want to know how many total chips. So then I'm going to go back and I'm going to go ahead and box in my numbers so that they're easy to find. And I've got to figure out, Marcel has 24 bags of chips. Each bag has 17 chips in it. How do I figure out my total? Do I do 24 plus 17? Is that going to tell me how many chips are in all 24 bags? No, not addition. I'm not going to subtract or divide those numbers. So that means I need to come over here and multiply. So just because your question might not be just looking, it might not look just like 24 times 17, we cannot forget how to do our multiplication. And it's super important, friends, that we know how to do this. Not that we know how to put it into a calculator. It's important that we can solve a problem like this on paper. You're not always going to have a calculator. So I'm going to solve this one standard algorithm, and then I'm going to solve an area model because those are my 2 favorite. Really, area model is my favorite, but I know a lot of you like standard algorithm. So my first step, 7 times 4, I know is 28. I'm going to carry my 2 over here. 7 times 2 is 14. 14 plus 2 is 16. I can get rid of those. I've taken care of them. I can get rid of my 7. When I get rid of my 7, I also come down here and give myself a placeholder 0 because I'm finished. My 1s are done. So there's nothing else that I can multiply that's going to give me something in the 1's place. 1 times 4 is 4. 1 times 2 is 2. When I add these up, 8 plus 0 is 8. 6 plus 4 is 10. Carry my 1. 1 plus 1 is 2. Plus 2 is 4. So it looks like my answer is going to be 408. I'm also going to do this area model. It's a 2-digit by 2-digit, so I'm going to have a 2 by 2 box. 24 times 17. 1 times 2 is 2. And then I have 2 zeros to put on top of that. Or to put beside that. So 10 times 20 is 200. 1 times 4 is 4 plus a 0. 4 times 10 is 40. 7 times 2 is 14 plus a 0. So 7 times 20 is 140. 7 times 4 is 28. So I'm going to come down 200. Remember, I always add greatest to least, just so I keep my place values lined up. 8. 4 plus 4 is 8, plus 2 is 10. 1 plus 2 is 3, plus 1 is 4. So I multiplied with both strategies, with 2 of my 3 strategies. I got 408 both times. So that I know is the numerical part of my answer, but then I also have to tell me 408 what? Does Marcel have 408 gummy bears? I would like 408 gummy bears. Does Marcel have $408? 408 turtles? We don't know until you tell us. We know we were looking for how many total chips. So our answer, when we write it out, will be Marcel has 408 total chips. So that one was only a 1-step problem. It only took us 1 step to figure that out. So far we've solved a 2-step problem, we've solved a 1-step problem. We figured out, we did them the same way. We went through our 3 steps before we ever began, and then we did the math. All right, the last one we're gonna look at. Eva has 13 trays of cookies. Sugar cookies are her favorite. There are 12 cookies on each tray. How many total cookies are there? Is there any information there that we just really don't need, that they've put in there because they've tried to give us more information and tried to confuse us? Is it important? I mean, I'm happy for Eva that she likes sugar cookies, but does the fact that sugar cookies are Eva's favorite have anything to do with the math we're doing? No. So that's not important to us. We're going to get rid of that sentence. Now we're going to reread it. Eva has 13 trays of cookies. There are 12 cookies on each tray. How many total cookies are there? That sounds a lot better. So now I need to figure out, what are they asking me? What's my end goal? What kind of answer do they want? I look for my question mark because that's my clue, and I see how many total cookies are there. So I'm looking for total cookies. I'm going to go ahead and box in my numbers because I know that's going to help. So if I know there are 13 trays of cookies and there are 12 cookies on each tray, I'm not going to add them because they're going to be a lot more than 25 cookies, and 13 plus 12 is 25. I'm not going to subtract them because, goodness, if we do 13 minus 12, poor Eva's only got 1 cookie. I'm not going to divide them, so I'm going to multiply them. 13 times 12. 2 times 3 is 6. 2 times 1 is 2. My 2 is finished. I'm also going to drop down and put my 0 because if I have nothing else that can be in my ones place, then there can be nothing here either. 1 times 3 is 3. 1 times 1 is 1. I'm going to add these up. 6, 5, 1. 13 times 12 is 156. I have the number part of my answer. Now I need the words. What did I answer? I answered total cookies. So Eva has 156 cookies. That's how many total cookies she has. That was a 1-step problem. It had some nonsense that we didn't need. We got rid of it because we don't want them to confuse us. So your 1 and your 2-step problems, you got to think, can I get rid of any of this? Is any of this junk that I don't need to know? What are they asking me to do, and how am I going to give them what they're asking?